Another hey from West Virginia. Oh well. But let's get joke of the day because that we can get right. So what did one wall say to the other wall? You know, like a wall in a room. What did one wall say to another wall? I'll meet you at the corner. Oh, these are great. I love joke of the day. So let's now talk about domain and range of relations and functions. Now, before we get into domain and range, let's review a little bit what relations and functions are. Remember, relation is the overarching main category. A relation is simply a set of ordered pairs. The order matters in these ordered pairs because the order determines what that relationship is. And we've talked about ordered pairs before that look like this. And typically, not typically, but always, we have the x-coordinate first and then the y-coordinate next. And the order matters tremendously because the order establishes that relationship. And it says, whatever I put in for that x, we're going to do something with it, and it's going to spit a y value out. That establishes the relationship. Now, when you have special relationships, those relationships become functions. And we've talked about functions before, and we said, okay, a function is a relation, definitely a set of ordered pairs. But in this particular case, for each and every x value, for every x that we put into the relationship, one and only one y value will come out. Only one y value will come out for that particular x value. So notice that everything we're talking about here is kind of like a machine. And remember I showed you my function machine before? And that function machine, we had an input that went into the machine. And this is a relation machine, but now let's talk about that function machine. Whether it be a relation machine or a function machine, either way, could be both. Could be either or. You're going to put something in, it's going to do its operations, its order of operations, and it's going to spit something out. So we have an input and we have an output within our machine. This input is what we call domain. Now, quite frankly, I've said many times, and I'll keep on saying it, mathematicians are not creative people. We call it like we see it, and I love that about math because it certainly helps. And we've talked about x-intercepts. It's where the graph crosses the x-axis. We talked about y-intercepts. It's where the graph crosses the y-axis. We've talked about the point-slope form of the equation of a line. If you're given a point and a slope, use point-slope. We've talked about how uncreative mathematicians are and how helpful it is because it helps you figure out what you're supposed to be doing. This is the one and only time where mathematicians got creative and I went, really? Because input was a perfectly good word. Why on earth did they change it to domain? I do not know. But what I can tell you is every time you hear the word domain in math, you should be thinking input. So whatever I put into my function machine, this is my domain. Now, on the flip side, whatever's coming out of my function machine, that is my output. We call this range. Again, output was a perfectly good word. Why did they change it to range? I have no idea. But when you hear the word range, you should be thinking output. Now, let's think equations. Let's take an equation like, say, for instance, this. We have y equals 3x plus 5. Within this equation, and we can even call it a function, remember once we've decided that it's a function and for every single input there's one and only one output, and we said, whoa, that one's special, so we're going to take the y and we're going to replace it with an f of x. Talked about that in a previous video. But the idea is this, whether you have f of x, whether you have y, they mean the same thing essentially. They both mean output. So my question is this, when you have something like this, whether it be an f of x or a y, which of those two do you usually input? Which of those two do you usually put your numbers into? Yes, in for your x variable. So your domain is usually going to be your x variable. If that's the case, which one is typically going to be your range? Which one do you usually have your numbers being spit out as your output? Yes, that's going to be your y. So your range is usually going to be your y variable. Now, a beautiful definition of your domain, a very good mathematical definition is, it is the set of values or the set of numbers that are allowable substitutions for the independent variable. So in other words, your domain is all going to be all the numbers that are allowed to be put into your equation, allowed to be substituted for your x. Now, this word independent variable, what does that mean? An independent variable is the variable in an equation that can be assigned any value. So in other words, my x here, that is my independent variable. So it is the one that I can put any number in for. It doesn't matter what I put in there. Now, sometimes there'll be restrictions on it, but for the most part, that is the variable that can be assigned any value, the x. The y is the one that its value depends on whatever I put in for x. The y depends on what I put in for x. So therefore, that y value is what we call a dependent variable. So the good definition, the very good mathematical definition of a range is it is the set of values that result from those substitutions for the independent variable. So your domain is the set of values that are plugged in, that are substituted in. Your range is all the values that come out as a result of whatever you plugged in. So therefore, your range is basically going to be your dependent variable. The definition of a dependent variable is it's the variable in an equation that depends on, there's your key right there, depends on the values that are assigned to that independent variable. And folks, it is much easier to identify your dependent variable than it is to identify your independent variable. The dependent variable depends on the other one. So as you look at this, which one of those two, the y or the x, which one's going to depend on the other one? Certainly, the y is going to depend on whatever I plugged in for that x. So therefore, the y is going to be my dependent variable. The y depends on what I plugged in for the x. So there's your definition of your domain. It's the input, typically your x variable, because it's the one that I plug numbers into. So therefore, it's my independent variable. And my range is going to be my output, typically my y variable, because that's the one that depends on whatever is coming out. That's the one the stuff's coming out, and it depends on whatever I plugged in. So let's play with this a little bit now, and let's figure out the domain and the range for several situations. So I have relations here that may or may not be functions. Right now, I'm not worried about determining whether or not they're functions. Right now, I just want to identify my domain and my range. Now remember, domain was which variable? Yes, domain was x. Range was which variable? Yes, range was going to be my y. So what happens here is, notice in the first two examples, I have a string of ordered pairs. So what I'm going to do here is I'm going to identify all the x values for these ordered pairs. So as I look at all these ordered pairs, I'm simply going to list my x values. So my domain is a set, so I'm going to indicate that with my braces. And now I'm going to list all the x values, starting with the lowest x value and working my way up to the highest x value. So the lowest x value that I see here is a -7. And now I'm going to work my way up. The next highest x value that I see is a -6. The next highest value that I see is a -2. Let's see, check these off. -7, -6, -2. The next highest value that I see is a 0. The next highest value that I see is a 3. The next highest value that I see is a 4. And then the highest value that I see is a 6. There is my domain. These are all of the x values for that particular relation. Now, let's check the range for that one. Remember, the range is going to be all the y values. So I'm going to look at my list of ordered pairs, and I'm simply going to list the y values, starting with the smallest and working my way up to the highest. So I'm going to start with my smallest y value, and as I look at all of these y's, the smallest is the -9. List it first. Then I'm going to work my way up in ascending order. The next highest value that I see is a -4. Now notice the -4 occurs twice. I don't need to list it twice because when it comes to domain and range, I really don't care how many times things show up. I just care what those x values are, what those y values are. It doesn't matter to me how many times that -4 shows up, just that the -4 does show up. So I'm only going to list it once. Now in ascending order, the next highest number would be a 0. After that would be a 5, and notice again the 5 shows up twice. I'm only going to list it once as well. And now the next highest value is going to be a 20. So here are all of my y values, so that's going to be my range. Now let's take a look at the next one. Very same thing. I'm going to identify my domain, which is all the x values, and once again I'm going to list them, and I'm going to use braces to indicate this is a set. So with domain being x, I'm going to start with the smallest x that I see, and as I look through here, the smallest x is a -8, so I'll list it first. And I'm going to go in ascending order again. So the next highest x that I see is a -4. And then going up, the next highest is a -3. Going up, the next highest is a 2. And going up from there, the next highest is a 4. And after that, the next highest is going to be a 9. And that's all my x values. So now I'm going to list my range. And remember, range is all the y values. So I'm going to start with the smallest y that I see and work my way up. And yet again, because this is a set, I'm going to list it with braces. And I'm going to start with the smallest y value that I see, and the smallest is a -5. Now I'm going to work my way up, and the next highest x that I see is a -2. And then the next highest that I see is a -1. The next highest that I see is a 0. The next highest that I see is a 6. And the next highest that I see is a 7. The next highest that I see is an 8, and I do believe that's all of them, and yes it is. So we've listed our domain, we've listed our range. Now, notice with the graphs, wow, this is going to be crazy to list domain and range. But if you'll notice in the first graph, these are individual points. That's what these were. These were individual points that I could have put on a graph. So what I'm going to do then to list my domain and range is I'm going to list the x values for those points. And for my range, I'm going to list the y values for those points. So what I'm going to do then is, once again, this is going to be a set of numbers. So I'm going to indicate that with braces. And I'm just going to start with the smallest x that I see. Well, my x's go through here, and the smallest x's are all over here. So as I start back here and work my way up, notice that when I get right here, there's a point. What is its x value? Its x value is -4. So therefore, the smallest x that I see is a -4. And as I work my way this way, the next x value that I see is right here. That x value is a -2. And then as I work my way this way, the next x value that I see is a -1. And continuing on, the next x value right here is a 0. Continuing on, the next x value that I see is a 2. And then continuing on, the next x value that I see is a 3. So there is my domain for that particular graph. Again, listing all of those x values for those points. Now what I'm going to do is list all the y values for those points. And again, what I'm going to do is I'm going to start with the smallest y value down here and work my way up. So when I list those y values, as I come up, here's a y value, and its y value is a -3. And again, I'm going to work my way up. Here's a y value right here of -2. And if I continue to work my way up, I've got a y value of 1. And if I continue to work my way up, I've got a y value of 2 right here. And notice that as I work my way up, this one has a 3, but this one also has a 3. But remember, we said I don't care how many times it shows up, just that it does show up. So I don't need to list that 3 twice. I'm just going to list it once. I care that it shows up, so I'll list it, but I don't need to list it twice. So here is the domain, and here is the range for that particular graph. Now, as we look at these graphs, notice that these are not individual points. These are a whole bunch of points. Because particularly if you notice at this graph, we've got, yes, an endpoint here. Yes, we have an endpoint here. And yes, we have an endpoint right here. But notice we've got a whole bunch of points listed through here. So it would be entirely too difficult when I go listing this domain. It is way too difficult to list -4, -4.5, no wait, -4 3/4, no wait, -4 7/8, no wait, -4.9, no, -4.99, oh no, -4.999. It's entirely too difficult to list all of these points. So what I'm going to do instead of listing out individual points, because it's too many, I'm going to say that these x values, they go from here all the way up to here. Because notice as I list each one of these, it's going from here up to here, right like this. So basically, the easiest thing for me to do to figure out what those x values are is to take this graph and just say, I'm going to squeeze that graph along this x-axis. And when I do, this point will come down here, this point will come up here. This point will come down here as well. This one will come down, and this one will come down, and this one will come up and up and up. These will come down, 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 down. These will come up, 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 up like this. So as I squish it along that x-axis, all of the x values that are being identified by that graph are all the ones from here to here. What are those x values? Well, it begins with a -4 and ends with a 0. So basically, I'm going from a -4 all the way up to a 0. That should look familiar. Yes, this looks like that interval notation. See, interval notation is super, super helpful. So I'm going to go from a -4 to a 0. Now, is that 4 included in the domain? Is that -4 a part of the graph? Yes, it is. That's a closed circle, closed circle. Closed circle indicates, yes, this is a part of the graph. So what am I going to put to show that it's included? Oh yeah, not a parentheses, but a bracket. Remember, brackets indicate that it is a part of the solution set. It's a part of the interval. Now what about this 0 right here? Is that a part of it? Yes. It also had a closed circle. And remember, if it's closed circle, it's included. We show that with the bracket. Now, let's talk range. Once again, range is the y value. So as I look at this graph, and let me get all this out of here, and I go, okay, when I'm talking about the y values, now as I go along this y-axis through here, well, I have a y value right here, and I have a y value right down here, but I also have a y value here. And notice I got y values all the way through here, all the way through here, and same thing happening down here all the way through here. So once again, the easiest way to identify those y values is to say, let's take this graph and let's squish it up on this y-axis. Now when I do, like I said, this point will come over here, this point will come over here, this will come over here and here and here and here, and all of these points will come over like this and this and this and this. And notice what y values are being indicated, what y values are being included by all of these points. Those are the y values from a -2 up to a 2, including everything in between. So once again, the easiest way to do it is not to identify it this way, because I can't list each and every one of those points. There's too many. So the easier way to do it is to say, well, this goes from a -2 all the way up to a +2. Is the -2 included? Yes, there's a closed circle there. Is the +2 included? Yes, there's a closed circle there. And so like before, we said to include them, we're going to put a bracket on it. So now let's look at this one. Actually, let's look at this before we go there. So that idea of squishing the graph, now remember, I identified those individual points, but if I want to do the idea of squishing the graph, and I want to do the domain, when I squish this graph, this one's going to come up here at -4. This one's going to come down here at -2. This one's going to come down here at -1. This one's going to come down here at 0. This one's going to come down here at 2. And this one's going to come up there at 3. So I can still identify my domain by doing that very same thing, squeezing it up on the x-axis. Now when I want to identify my range, I can do the same thing that I did over here, and I can squeeze it up on the y-axis. When I do, this one comes over here at -3. This one comes over here at -2. This one sits right there at 1. This one comes over to 2, and these both come over to 3. So once again, I can use the idea of squishing the graph in order to be able to identify my domain and my range. Now, let's look at this one. Once again, domain is which variable? X. So I'm going to take this graph here and I'm going to squish it up on the x-axis like this. So this will all come down through here like this, covering all of these x values. These will come up through here like this, covering all of these x values. But notice, what does the arrow mean? Oh yes, the arrow means this is going forever in this direction. So it's going to keep on squishing, squishing, squishing all the way out here. It's going to go on forever. And the same thing over here. That arrow indicates forever in this direction. So these are all going to come up like this, indicating this is going on forever in that direction. So now what x values are being included in that graph? What x values are being mentioned by these points? Yes, every one of them. So in an interval notation, again, because I can't list these as individual points like I did here, these were individual points, these are not. Look, these are continuous. Too many points to list because it's a continuous graph. This is not a continuous graph. Since it's not continuous, I can list individual points. This was continuous, not individual points, so I have to list it in an interval notation. This as well is continuous. So I cannot list these as individual points. So therefore, my domain, what x values got covered? Everything from negative infinity all the way to positive infinity. So my domain then is going to be negative infinity to positive infinity. And as we discussed before with interval notation, infinities always get a what? Yep, always a parentheses. They do not get brackets because you cannot cap off infinity. You can't cap it off and say that's the end of infinity, because infinity goes on forever. Since you can't cap it off and say that's the end of it, it has to get a parentheses. Now, let's look at range. Remember, range was going to be all those y values. So let's take this graph and let's say, well, now, if we take this, and since it's continuous, I'm going to squeeze it up like I did that other graph. And if I squeeze it up on this y-axis right through here, then what's going to happen is all of this here is going to come over like this, like that, and these y values are going to get covered. All of this is going to come back here like this because I'm squeezing it like this. So all of these are going to come over here, and these y values are getting covered. But again, the arrow indicates what? Not only is it going forever this way, it's going forever this way. So it's going to keep on going up, 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 up forever. And this arrow not only indicates it's going forever that direction, but it indicates it's going forever this direction. So it's going to keep going down, 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 down forever. Now, what y values got covered? Yes, all of them. So on that interval, it goes, again, from negative infinity to positive infinity. And just like before, we said, okay, infinities are always going to get a parentheses because you cannot cap that off. Now, let's look at this one. Once again, to identify domain and range, we're going to squeeze up that graph. Domain was which variable? Yes, domain was x. So we're going to take this graph and we're going to squeeze it up on this x-axis. So all of this is going to come down like this, down, 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 down. All of these x's here are going to get covered. And on this, when I squeeze it up on that x-axis, these are all coming down, 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 down. These x's are getting covered. And once again, the arrow indicates forever in that direction. So forever like this. This arrow indicates forever in this direction. So forever like this. Now what x's are being covered by that graph? What x's are being mentioned by the graph? Yet again, you're right, everything from negative infinity to positive infinity. And once again, in an interval notation, and we're going to list it in interval because these are not individual points. This is a continuous graph. Continuous is a tip. Oh, that will be an interval. And all those infinities get parentheses because we cannot cap off infinity. So now let's look at range. So with the range, once again, that's going to indicate y values. So we're going to squish this up on that y-axis, and when we do, all of this comes over here like this, and these y values are getting covered, and all of this is going to come back over here like this, and all of these, same y values getting covered. The arrows are indicating it's going forever, not only in these directions, but in these directions, so it's going to continue to go up, 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 up forever. What y values are getting covered? Everything up here. Now, is anything down here getting covered? No, nothing down there. Only from here up. So what is this point right here? Yes, that's 0. Y is 0 right here. So we're going to go from 0 forever up. So we're going to go from 0 to infinity. Infinity always gets a parentheses. How about that 0? Does it get a parentheses or a bracket? Is it included in the graph or is it not included? It was a closed circle, so it gets a bracket to say yes, it is included. Okay, we're going to take a look at a couple more graphs because these other two graphs kind of throw us off a little bit. So hold on just a second. Okay, so let's take a look at these last two graphs. And once again, we're going to identify the domain and the range. Remember, the best way to do it with a graph is to squish that graph up on the axis that's needed. So remember, domain was which variable? X. So I'm going to take this graph, I'm going to squish it up on this x-axis. Now when I squish it on this x-axis down here, everything's going to come down here like this. And notice again, the arrow indicates it's going forever in that direction. This arrow indicates it's going forever in that direction. So all of these x's are going to get covered, all these x's are going to be included, and it's going to go forever like this and forever like this. So what x's are included? Yes, all of them, from negative infinity to positive infinity. So once again, we're going to get a negative infinity to positive infinity as our domain. And like we said before, infinities always get a parentheses. Now let's take a look at the range. Remember, range was the y variable. So we're going to take this graph, we're going to squish it up on this y-axis. Notice what happens here. When it squishes up on the y-axis, it squishes here, and this squishes back here. So that it all squishes to this point right here. So therefore, what is the range for this particular graph? There's only one value, that one right here, which is 1, 2, 3. So the range for this one is a positive 3. And it is just a 3, so to indicate that, I'm going to give it braces for a set. It's okay to have a range that is only one value, because this being a horizontal line, that's going to happen. With that in mind, let's take a look at this vertical graph, the vertical line here. Once again, a domain being the x, I'm going to squish this up on that x-axis. So this is going to come down through here. This is going to come up through here, and once again, only one x is being identified, only one x value. In other words, every one of the points on this particular line, all the points down through here, every one of them have the same x coordinate. Every one of them have a -4 for that x. By the same token here, every one of the points on this graph, every single one of them had the same y coordinate. All of them have a y coordinate of 3. So here again on this one, that domain, squishing it up on that x-axis, squishes into that x being a -4. That single point is going to be my domain. Now for my range, again, squish it up on this y-axis. When I do, all of these will come over like this, and all of these will come over like this. And again, this arrow indicates forever up that way. This arrow indicates forever that way. So what y values are getting covered through here? Absolutely every one of them. From all the way down here, forever down is negative infinity. Forever up is positive infinity. And we said before, infinities always get a parentheses. So, I hope that helps you with the idea of domain and range. Whether you have a graph, whether you have a list of ordered pairs, or any of that, domain is always going to be your input. Therefore, domain is going to be typically your x variable. Range is always going to be your output, typically going to be your y variable. So I hope that helps. Have a great day.